I'm sorry, I can't hear you.
Just for the recording, do you mind just repeating exactly what happened just in a nutshell?
Yeah. Again, all that we did is hit the on button, and the unit did everything else. So we had done our prep walk. We made sure everything was nice and visually okay. We went ahead and put the isolation switches in auto, and that would basically allow the system to do everything on its own. We started in bypass because that's normally what you're going to be doing, is starting in bypass. But all we did was hit the on button, and at that point, that gives a command for the diesel to start. So the diesel starts. As it comes up to speed, it brings the shaft up with it because it clutches in directly. The shaft comes up to 1800 RPM. Then after a little bit of time, there's a timer involved. It will start to energize the DC windings in the outer rotor so that it can start bringing up that inner rotor to match the shaft speed of 1800 RPM. But once that is done, the DC injection is stopped, and then the flywheel is brought up further by the variable speed drive in the USP panel. Meanwhile, as all that is happening, we are synchronizing to the utility, and the system will go ahead and close the Q1 breaker. As the Q1 breaker closes, the diesel will come down to idle speed, it'll go through a brief cool down, and then it will stop completely. And then at that point, we're just waiting for the flywheel to come up to maximum speed from the variable drive. That takes about 10-15 minutes or so, as we saw. Once it is up to full speed, everything is basically the way it's going to sit for normal operation. We can return from bypass. That's when the operator would then hit the UPS button to take it out of bypass, and then we're serving customer load with UPS. Just one more time. So I'll try and write out the steps on the board here. So first I'm going to assume that we're in bypass. The system is down, it's not running, but it is in bypass. So let's just say that we are start in bypass. Q3, okay? And then this is up to, you can do it either way. You can actually have the Q1 and Q2 ISO switches in trip if you'd like, or you can put them in auto. If you put them in auto, then the system will basically do everything on its own. You don't have to, it's not going to wait for you to close Q1, it'll do it on its own. But that's something that is up to you on whether, which method you want to use. The manual is going to tell you, put the switches in trip, because the manual is kind of defaulting to, giving you complete control. But I would go ahead and just put everything in auto, because that gets rid of all the alarms. That, clears out your HMI alarms. So I would say put all ISO switches Q1, Q2 in auto. Okay? I would just go ahead and have them in auto. That way you can clear all the alarms on the HMI. Start with a nice clean slate. And basically, we're just going to press the on button on the HMI. What follows is going to be the machine doing everything on its own. Okay? So, let's say this is an operator action, this is an operator action, this is an operator action. Next steps that occur are going to all be machine actions. I'll just call it M, right, for a machine.
Is the key switch in local at this time?
Oh, yeah, the key switch has to be in local. That's a good point. You've paid attention. I'll put that as step 0, actually, okay? Place HMI key in local. Okay, operator action. Okay, so basically those four items. So what's going to happen after you press the on button is the diesel will start. Okay. By virtue of the diesel starting, the clutch is going to engage instantly because the shaft is not spinning. So,
Zero, right?
yeah, the shaft is at 0. So the diesel automatically matches the shaft speed to begin with. It's going to clutch in immediately. So, free-wheel clutch will engage, and shaft driven to 1800 by the diesel. Okay? So, by virtue of the shaft coming up to 1800 RPM, that means you're going to start producing a frequency of 60 hertz. So at this point, your alternator which now functions as a generator, will start its AVR, its voltage regulator. It will basically excite the AVR and to bring voltage to 4160. Okay, so the shaft will come up to 1800 RPM, and then the AVR will turn on for the generator. It'll excite the generator itself, and it'll bring the voltage up to 4160. So you'll see that on the HMI. As the speed comes up, the frequency will come up, and the voltage will come up. This is all automatic. All right. Something I didn't mention earlier, but if you're looking at the true steps of what you can expect to see is once the diesel comes up to speed and is at 1800 RPM, and as soon as the frequency and voltage is stable coming out of the generator, then we're going to go ahead and start the radiator. Okay, we do not start the radiator immediately when the diesel starts, because we want to wait until the output voltage and frequency is nice and stable before we start the radiator. Now you can run that diesel without a radiator for a while, and you don't have to worry about overheating the diesel. So it's okay to wait to start the radiator. So after we get good stable output voltage and frequency, really the next step that's going to happen is the radiator is going to start. Okay, so your roof mounted radiator, the fan will start to spin, and now it can actually, start cooling the engine. That's assuming that the thermostats on the engine are open, which they might not even be open at that point. But again, that's a load step that will happen next once the output voltage and frequency is nice and stable.
How would this happen when it gets warm enough, right?
The thermostats on the diesel will open per the diesel command. When the diesel reaches,
Start the radiator fan.
yeah, as soon as the diesel temperature reaches a certain level, it'll open its thermostats. It'll start sending water to the radiator, but the fan will still already be running. Okay. So the next, and again, our PLC is regulating all this, and it's making sure that everything is nice and stable. So, it's going to make sure that voltage and frequency is stable before it starts the radiator, and then it's going to make sure that voltage and frequency is stable again before it takes the next step, which is energizing the DC windings in the outer rotor of the flywheel. So we're going to energize those DC windings, and then the outer rotor of the flywheel is going to grab onto the inner rotor and bring it up to 1800 RPM. And if you happen to be standing in front of the HMI to see that, you'll note that that comes up pretty quickly. It pretty much goes from 0 to 1800 very quickly. Okay. Step 9 is once the DC has brought the flywheel up to 1800 to match the shaft speed, then we're going to stop the DC, and then we're going to start to energize the drive, the variable drive, to start bringing the flywheel from 1800 to 4200 RPM.
That's powered by the pony motor.
That's what?
That's the pony motor.
The pony motor, yes. Well, the drive that drives the pony motor that brings the flywheel up to speed, right?
The pony motor is coupled to the inner shaft and it's driven by the VFD.
Correct.
So the pony motor doesn't have anything to do with turning the inner rotor until the DC windings bring it up to
Yes.
1800.
Correct. Yeah. The pony motor won't even turn on
Right.
until we're at least at about 1800 RPM. Okay. So the VFD will come into play then, and it will take the flywheel from 1800 all the way up to about 4197 is what it tops out as. And that can take some time. As you noticed, it can take 10 minutes, 15 minutes. It slowly brings it up to maximum speed.
Once that VFD starts, your DC windings are de-energized.
Correct. Yeah. Yeah. Before this happens, we'll actually de-energize the DC windings. Now, kind of while this is happening, while the VFD is coming up to 4197, so this is not necessarily in order, but at some point within this time, we're going to go ahead and synchronize to Q1, and the system will close the Q1 breaker.
At which point you're getting utility power to feed the generator and uncouple the shaft.
Correct. Right, because we're going to synchronize the diesel to the utility, going to close the Q1 breaker, and then it will immediately fall down to idle speed. At the same time, instantaneously, our alternator switches modes from being a generator to being a motor. Instantaneous. To idle. Okay, so again, this will happen before this actually reaches full speed on your flywheel, but we're going to sync the utility, close the Q1, diesel will drop to idle speed, and then it's going to cool down for about a couple minutes. Also, free wheel clutch disengages. Next step is stop diesel. This is again M. This all happens automatically. And that's pretty much the end of our stop process. At this point, the diesel is stopped. The system is in normal operation. Q1 is closed. We're still in bypass, but the system is basically running off a utility in normal operation. So step 12 would then be take out of bypass. Close. close Q2, open Q3, and that's an operator function.
Wait till you get to that 4197.
Yeah, right. Yeah, you would be at 4197 before you would start this process. Okay. So operator action, to start the process until you hit the on button, the machine does everything on its own from there. The only thing you're doing at the very end is taking it out of bypass. Okay, but that's your normal start sequence.
Generally, you're gonna one will close and the diesel will be off long before your inner shaft is up to 42. Generally.
Yeah. And for a start, the Q1 will close long before you're at full charge. That's why you should probably wait until you're at 4197 before you come out of bypass. You don't have to, but it's common practice. We just say, come out of bypass when you know you're fully charged. Okay? But this is pretty much what you'd expect to see, in the sequence. So if you're kind of just during the process thinking along, just watching things, that's what you're looking for, just to make sure that process happens. And then once you're out of bypass, walk away. You're protected at that point. Okay? So we also did a diesel test. We did a system test, and then had you just open the Q1 breaker, sort of like simulating a utility outage, and saw the diesel came up, handled the outage. We enabled Q1 to close, it reclosed, and returned back to normal. So that's pretty much the extent of really what you're going to have to deal with the unit. Now, we didn't shut it down. We're going to go ahead and leave it running. There's no need to shut it down, but if you were to want to shut it down, it's recommended first you go to bypass first and hit the off button. And then again, it'll do everything on its own. Even if you forget to go to bypass and hit the off button, it'll still go to bypass first, and then it'll shut down. So that's, again, pretty much the extent of what you should have to deal with as an operator.
So in the configuration we're in right now, is that TR52 open or closed?
Right now it's open.
It's still open.
Yeah, it's open. So tomorrow morning, Stanley is going to go through the process of putting the load back on the unit.
So right now it's not feeding anything.
No, it's not. Now, again, they had to put a jumper in the Q2 breaker to enable us to close the Q2 because their safeties and how they're configured right now to kind of wrap around the system. That's why the jumper's there, but they'll take the jumper out, and then tomorrow morning again
So it's got to be tied to 52 then, right? It's got to be closed.
It's actually tied to the tie breaker, the DG tie breaker, I think. It depends on the position of that tie. If it's closed, then it inhibits the closure of Q2.
Oh, I thought that was renamed. Okay,
Yeah. That's something that Stanley is involved in as far as how all that works outside of the high-tech system. All I know is that we have certain interlocks that were placed to prevent us from doing certain things if other external breakers are open or closed. So I can't really speak to that. That's Stanley's scope as far as figuring all that out, but that's why we couldn't close Q2. We had to put a jumper in there to enable that. But in normal operation, that's a special evolution that's only going to happen on special occasions, and that'll, Stanley will put together an MOP that dictates how that process runs. Okay, but as far as the high techs are concerned, we're only worried about what comes into the high tech and what comes out of the high tech. Okay, all right. So, any questions in closing?
So, yeah, I got one.
Yeah.
So if you're in utility mode,
Mm-hmm.
and right now you can't feed anything, if you went to utility, we would only put 50% load on it back to the utility, right?
If we went to ULT mode,
Yes.
okay. Again, ULT mode depends on, is the Q2 breaker open or closed? So right now, the Q2 is closed. So if we went to ULT mode, then the maximum amount of power that we would export into the utility is 50% of the rating of the system, because there's no load on the system.
Right.
So we can export up to 50% with Q2 closed.
I'm just thinking ahead of how they're going to do their monthly tests.
Mm-hmm.
And I don't know if Mark's going to want to do it with 52 closed. If there's a oops or whatever, it should never happen.
No.
But I'm thinking that's why that's like.
Well, I think it also has to do with special ways to bring around utility to different buses, wraparounds and things of that nature, or tying in your generator sets to have them serve certain buses. I don't know all the different combinations that can occur. Yeah.
Can I give you a little bit to go over the monthly procedure we should be going in to energize this and close everything in and then do our monthly tests?
So again,
Can we go over like maybe just me and you what our monthly test is going to be and how to perform it and to get the diesel generator running?
yeah, we can do that.
Okay.
At-
Shouldn't take very long.
At the end of the day, really what you do is up to you. It's your machine, but we have recommendations that that we put out in our manuals that I can go over with you.
Okay.
Okay. All right. Well, if that's it, then that concludes the training. Again, I'm going to take all your information. I'm going to send you the training materials. I'll send you a course critique if you want to go ahead and fill that out and return that. Other than that, any other further questions you have, contact High Tech Service helplines. When I send you this information, you'll have my information as well. So my email will have, my return email information and phone number. So you can always contact me as well if you have questions. Typically, if it's something as far as operating the system, I let the service guys go ahead and be the first to answer those questions. But if it's something that has to come to my level, then I certainly will answer it. Okay.
Your Excel files, as far as checks, will that be with what you sent us, or that is coming with the?
I'll send that to you.
Okay. Thank
Yeah,
you.
yeah. Everything that I've shown here in this training, I will send you a copy of.
Great.
You'll get an additional copy of it with all of our manuals as well, but yeah, I'll have no problem sending you more than you need. So I'll put that in the package. You should get that over the next few days or so. Okay.
All right. Well, thanks for your help. Thank you.
All right.
Yeah,
No,
thank you.
thank you guys. Appreciate it.